All right, good morning, everyone. All right, this is our last push towards our AP exam, which is next Tuesday, or this upcoming Tuesday. I included this document on my website under today, so hopefully you guys at home you're able to print this out or just kind of follow along. The first page is exam details. I'll talk about AP exam details. And then on the back, I'll go over some tips, advice, and I think I also want to talk a little bit about derivative rules and formulas and patterns. And I think that will be good to go over. Okay, so let me know if you guys have any questions as I go through the exam details. So first, your exam is Tuesday, this upcoming May 4th, 8 a.m. For many of you, this will probably be the first AP exam that you take this AP period coming up. So the exam is this exam is approximately 3 hours and 15 minutes long. There's two parts. There's multiple choice and free response. All right, we've been kind of going back and forth between multiple choice and free response. Each section is worth 50% of the final exam grade. So first part is you're going to start with multiple choice. Okay. In total, there are 45 questions, and it'll be a total of 1 hour and 45 minutes. Okay. So part A, you're going to start off with the non-calculator portion, 30 questions in 60 minutes. Now, think about the multiple choice test that you just took with me. I gave you two half-hour periods, basically an hour, maybe a little bit more than an hour when we add it all together, for 16 multiple choice, right? And now you got to do 30 questions, 30 multiple choice questions in that 1 hour time period. Now, for my exam, you guys, I wanted you guys to show work, right? Because work was part of the credit for earning it. So, but obviously here, you know, if you know what the answer is, you don't show any work, right? You just work is only there to if it helps you process the problem. So obviously no work, which means that you'll be able to move faster through the problem. But still, right? That's a lot. 30 questions in 60 minutes. So just, you know, that's averages out to be about 2 minutes per problem, right? So most likely you will be rushed for time. So just understand that. Going into the exam, that first part, you're going to feel that time crunch. Everything after that is going to feel a little more relaxed in terms of the amount of time that you have, but that very first part, you're going to be rushed. So just, you know, prepare your, you know, your mindset for that. Now, when you get, when time is called, then you move on to the second part of the multiple choice question, multiple choice portion. 15 questions, 45 minutes. So this is going to be a graphing calculator portion. And you're going to have an average of 3 minutes per problem. So this is, you know, this is kind of like a pattern that I see from students year in and year out is they're rushed for time for part A, and then they're sitting for part B with 10 minutes left over, and there's nothing more to do because you've already answered all the questions. And it's just strange how they kind of divvy the time. It's actually better. It's better than before. Before that, you had even less time for part A. At least they've gotten it up to 2 minutes per problem. But it's just strange, right? That part A, you're rushed for time, and part B, you have too much time, and you wish you could take that portion and work on some of the problems that you didn't get to work on for part A. But you know, that's just a quirk that you have to just I don't know why, but that's just why. That's just how they designed the exam. Okay, so the total scores on multiple choice sections are based on the number of questions answered correctly. Points are not deducted for incorrect answers, and no points are awarded for unanswered questions. So make sure that that you answer every question. There's no penalty for wrong answers. Okay, it's like the SAT and ACT, right? Answer every question. And then after you get done with the multiple choice section, you'll have a 10-minute break. Okay. You get to stretch, go to the restroom. You get to kind of move around a little bit away from the, I think they'll put you out in the hallway or near the bleachers, but you'll be away from the testing region. You have a 10-minute break, and then you'll come back and you'll take the free response portion. Okay. Now, for response, you have 6 questions and you have 1 hour and 30 minutes. Okay. Part A, you're going to start off with the calculator portion. Okay, so you're going to start off, you're going to have there's going to be a booklet, and that booklet is going to be all 6 problems inside that booklet for your FRQ. Okay, you're going to break the seal, and you're just going to be working on 1 and 2. Okay, 1 and 2 with the calculator. And you have 30 minutes to work on those 2 problems. You can move back and forth between those 2 problems, but you can only look at those 2 problems for in a 30-minute period. Keep in mind, graphing calculators are permitted. 36 Pro is not on College Board's approved list. So if you bring 36 Pro, you gotta just have to, you're taking that chance. So hopefully you have a graphing calculator and you can bring that to the exam. After 30 minutes is called, okay, you have to put away your graphing calculator under your desk, and then we can start part B. Part B has questions 3 through 6. You're going to break the seal, and then when time is called, you can start working on questions 3 through 6. You have 1 hour to work through those 4 problems, but roughly averages out to be about 15 minutes per problem. Okay, this is something that a lot of students did not know, and I want to make sure that you guys know this. You can still work on numbers 1 and 2, even though you don't have your calculator anymore. So a lot of students, they feel like, oh wait, I got done with 1 and 2, calculator is removed from the desk, I can only work on 3 through 6. Okay, it's all in the same booklet. You're allowed to work on 1 and 2, just don't have your calculator. So what you want to potentially do is, if you're running out of time for 1 and 2, try to do all the parts that you feel like involve the calculator, if it's possible, because that you can always, if you have time after during questions 3 through 6, you can always go back and improve or add to your answers for 1 and 2. You can still work on 1 and 2 just without a calculator. Okay. Okay, I want to make sure that's clear. A lot of students, they were like, "Oh, I had no idea I could work on 1 and 2. I wish I could have. I wish I'd known that, because it was half finished." Right. So go back and work on 1 and 2 if you need to. Okay. So both parts, multiple choice and free response, is going to be 54 points, and so it's going to total out to be 108 points. Free response is 9 points per problem, so 9 times 6 is 54, but multiple choice is only 45 questions. And to get to that 54 points, what's going to happen is you're going to, however many questions you get correct, they'll multiply that number by 1.2 to get it up to 54, so that these are matched evenly, and then your total exam raw score is out of 108. And this is from 2012, but at least you kind of have an idea as to what it takes to earn a 3, 4, or 5. To earn a 3, if you get a 41 to 56 out of 108, right? Somewhere in that 30–40% range, that's good enough for a 3. Somewhere in that 50% range, if you get 50% of your exam correct, that's enough to be a 4. And then this may be a little high. 68 may be a little high. It may be closer to 63–64% to earn a 5. But that number fluctuates, right? So I think they have a formula, and so that number, but at least you have some general idea of what it takes to earn a 3, 4, or 5 on the AP exam. I guess in the sense it is a pretty generous curve, but at the same time, these questions are not easy either. So, getting 50% on the AP exam, I think that's quite an accomplishment. I mean, it does definitely show that you have a pretty strong understanding of concepts studied in the course if you can get 50% of the questions right? Because it covers so much, right? And you're not going to be able to answer every question correctly, but hopefully you'll be able to get in that in this range to earn a 3, 4, or 5 on the exam. Okay, so on the day of exam, you're going to hopefully be at the gym by 7:45, so you can get settled, and then that they can start seating you in the gym. Bring your graphing calculator. Make sure you charge your calculator the night before. Check your batteries. Maybe it's best if you just have just additional batteries on you in case something you're not for some reason your calculator runs out and because yeah, and some unforeseen unexpected occurrence, you have some backup. Bring 2 or more non-mechanical number 2 pencils, and then also bring black or blue pen. Oh, well, this was I forgot to mention from previous classes, you can work on your exam in pen if you want. Okay, for response, you can work in pen if you want. If you're more comfortable writing in pen. Multiple choice sections, sure, work in pen, but if you want, but when you get to the bubbling, then you want to make sure that you use a number 2 pencil. I don't know if there's an issue with a mechanical pencil, but I feel it's just safer to have a non-mechanical pencil. Just, everything shows up better. Yeah.
You have to use a black or blue pen.
Oh. I think that's what they prefer. I've graded AP exams where I see like pink or just like really strange colors, but black and blue ink is going to be the easiest to come through for graders. So, that's a good question. I don't know if they're going to ask. I don't think that's a requirement, but I think those are the preferred ink colors.
It has to be a pen, right? You can't use a pencil.
You can. Yeah. You can use pen or pencil. You can use anything you want, but the only requirement is that when you bubble in, that you're using a number 2 pencil. But yeah, you can use a pen or a pencil on FRQs. I think on other exams, they're asking, students have to write in pen. I do feel, though, that pen do come across better for graders because you're writing on a gray sheet, and pencil sometimes is kind of hard to read for graders. But do whatever is comfortable, right? Don't worry about if you're more comfortable writing in pencil, then do it. But at least you have that ink, you have that blue or black ink option in case you want to do that. Bring water. Bring extra long sleeve shirt. Sometimes people think the gym is colder, so just bring extra long sleeve to layer in case you feel cold. Okay, any questions so far? I'm moving into more the tips and the back page. But any questions about format that you guys have? Anybody on Teams? Yeah, if you think of something, don't hesitate to reach out to me through Remind so I can help answer your question. Let's see. Okay, FRQs. Careful with linkage errors. I think I talked about this before, where on FRQs, really be careful of how and when you use your equal signs. I mean, if you never use equal signs on FRQs, that's even better because then you don't have any, because graders are always looking for these linkage errors. I see students, they have equal signs all over the place, and this, everything is linked together, and this should be equal to that, and it's not, and I got to take off a point. So, yeah, try to use arrows on FRQs. Multiple choice doesn't really matter. It doesn't matter at all, but FRQs, they're looking at your work. You either use arrows or just don't use anything, right? Just go from one step to the next and make it where students can kind of go through. Oh, okay, thank you. Appreciate it. Okay, yeah, try to minimize your use of equal sign. That's just a safer thing to do, especially on L'Hopital's rule problem. This is where, when I was grading in the past years, this is where a lot of students lost points because I think it's because we do it in class. We do equals 0 over 0, and then we do L'Hopital's rule, but they take points off for that. So just use arrows for L'Hopital's rule everywhere. Just use arrows for L'Hopital's rules. Arrow 0 over 0, arrow limit, and then derivative and arrow to your answer. Okay. That's a safe thing to do. Okay, questions? Okay, let's go to the back. Highlight a few things here on the back. Okay, again, answer every question, no penalty for wrong answers. Okay, if you arrive at your solution without using derivative, slope, integral, area finding formula, reconsider your approach to the problem. I read this somewhere. It says, when in doubt, take the derivative. That's kind of an oversimplification, but majority of the problems does have that derivative as its first step. So if you're struggling with what to do there, maybe find the derivative will kind of help jog your memory as, oh wait, this is mean value theorem, or this is extreme value theorem, or Rolle's theorem, or second fundamental theorem. As complex as the problems can look, just know that the exam creators are restricted. They're restricted to the type of questions that they can ask, right? They're not gonna, the graders are never going to pull the problem from physics or something that is completely unrelated to what you're taking the exam for. But however, they may try to find a creative way to see if students can make that connection, with related rates, or but they may present something a little bit more uniquely. But just try to look for those things, right? It's like, oh, is this EVT? Is it mean value theorem? Is it IVT? Right? Go down that checklist, right? There's only a number of things that they can ask you about. So try to categorize it, right? Try to categorize into which problem, because then you can kind of maybe see an opening into working through that problem. All right. That time issue that you're going to run into with that first 60 minutes of your exam, you're going to be rushed. So make sure that you don't treat every problem equally. And what I mean by that is search for the easier problem first, right? So if number one on the exam is a solving differential equation where it's going to take 5 minutes to do, skip it, right? Don't do that problem first. Do the easier one first. Do the quick problems first, right? I would much rather you get stuck at the end working on a final difficult problem that you didn't get to because you're working on all the easier problems, rather than working, on the 30 question problem, you're only on number 23, and you're working on difficult problems, but you never even got to see the last 7 problems because you ran out of time. But maybe half those problems are easy that you could have gotten through in 1 minute. So make sure that you read through every problem. Even if you don't know how to do every problem, read through every one of them. So to ensure that, just even if it's a differential equation where you're like, all right, I know how to do this, maybe just circle it and come back to it, right? Save the differential equation problems for later, even though you know how to do it. But there's so many steps for differential equation, and it's worth the same point as a much easier problem, right? So that's my preference. Like, save the differential equation, even though many of you feel really comfortable with it. Save it to the end. Do the quicker, easier, faster problems first. Let's see. Yeah, FRQs, try to write neatly. I know that may be kind of hard because I know you're rushed for time on FRQs as well, but just try your best. Oh yeah, don't bother erasing. Just cross out, right? Just do a clean cross out. You don't have to try to hide everything because graders are instructed to ignore anything that's crossed out. So, if you have something incorrect and it's crossed out, graders are not going to look at the crossed out section and say, oh, there's a linkage error, I got to take points off. They're instructed to stay away from anything crossed out. So you don't have to, erase, or you don't have to think about, oh wait, the grader can see this even though I crossed it out. What if they read this and think it's part of my answer? So don't worry about it. Just do a clean, clear cross out, and then you'll have plenty of space to work on FRQs. So don't bother erasing. Yeah, I'm not going to go through every one of these, but I think it's worth your time to kind of read through and then reach out to me if there's something that that is on here that's not clear. Yeah, sometimes I see students struggling looking at integral problem. They don't know how to start the problem. Chances are it's a use substitution problem. If it's a problem that is complex and because there's a part within the part, most likely it's a use substitution problem. So if you see an integral problem, try to find that u value, right? And the purpose of u substitution again is after u substitution, it should match up with one of these known rules that you see in front of you. That's on the formula sheet. Okay, this next step here, this next tip, make sure that if you see a trig function and it's written in the shorthand form, that you rewrite it, especially if it's one that is asking you to find the derivative, right? Rewrite it so you can get it ready for chain rule, so more visually you can see that outside, inside, inner portion kind of all working together. Also, this is the way that you would enter in the calculator as well. Okay, there's no ability to put in the calculator as cosine cubed. You have to write it as cosine 4x bracket cubed to graph it in the calculator. Let's see. Okay, let me talk briefly about memorizing derivative rules, especially the trig rules. So what I would like for you to do is when you get your AP exam, especially that multiple choice section, because this is where potentially the most rules are going to start coming out in that section, I want you to write down the 6 trig derivative rules at the top of your page. So the first thing you do when you get that multiple choice test, just upper corner, just write down the 6 rules. Okay, because the 6 rules that you're going to create are really 12 rules. Okay, so let me kind of show you what I would like for you guys to do, since they won't give you any formulas. And the trig ones are the ones that we can just quickly get a handle on. So this is my preferred form in terms of writing your trig derivative rules. And also, you picked up this formula sheet a while back, and I also have it under Monday's dates if you want to print out and just get extra practice, because I have the blank copy and I have the key copy where you can kind of go back and forth. And I grouped them in places where it's easy to hopefully memorize and see patterns. Okay, thanks, John. Okay, so this is what you're going to do. At the top of the page, you're just going to write down sine, cosine, tangent, cotangent, secant, cosecant. Okay, in this order, in this pattern. So what I want to show you is sine's derivative is cosine. Let me just kind of go through and show you why I like why this is conducive for easy memorizing. Cosine's derivative is negative sine, right? You guys know this. These are the ones that are the most basic, the ones that show up the most. I like putting tangent and cotangent next to each other because their derivatives have a similar form to each other. So tangent's derivative is secant squared u times u prime. Cotangent's derivative is negative cosecant squared u times u prime. And the interesting thing is that sine and cosine, they involve each other's in terms of the derivatives. Tangent and secant, they involve each other for the derivative rules. And then cotangent and cosecant, they involve each other in their derivative rules. But you see the similar pattern, right? They both have squared in them. And then secant and cosecant, secant's derivative is secant u tangent u times u prime. So look at how secant derivative just involves the ones that are next to each other. Cosecant's derivative, very similar pattern, negative cosecant u times cotangent u times u prime. Okay. So hopefully having those patterns is helpful. I want to point out a few more things here. Look at these functions. Look at all the ones on this side. You see how they all start with C? All the trig functions that start with C are negatives. So that's nice. That's a nice pattern to have. That's why I like to organize the C functions, derivatives. You know, they can just put all negatives there. Good reminder. And also, I have this in alphabetical. The C are in alphabetical order. So if you can, practice this on Monday, write the 6 rules, see if you can quickly get to them, and you have 6 rules in front of you. But what I want to show you is that you actually have more rules. This is actually showing 12 rules because these are showing you 6 derivative rules, but it's also showing you 6 integral rules. So let me show you what I mean by that. Remember, integral rules are just going backwards from the derivative rules, right? So let's say you want to decide what rules you have in front of you for integral rules. What you can do is this. The integral of cosine is going to be sine. And that's here, right? We have the 6 integral rules, but you don't have to memorize these, right? Just pull them from the derivative rules because you're just working backwards, right? The integral of cosine is just sine. So if you just put an integral next to the function, then whatever's to the left of it is going to be your integral rule. So the integral of sine, that negative is going to have to go somewhere, so it's going to be a negative cosine. So that's the rule here. Integral of sine is just negative cosine. Right. Integral of secant square u du is just tangent u plus c. Integral of cosecant square u, that negative is going to go over here, is negative cotangent u plus c. The integral of secant u tangent u is just going to be secant u plus c. The integral of cosecant cotangent u du is just negative cosecant u plus c. So I really think this is helpful. Put this out top of the page. You have 12 rules in front of you, and then that way you can continue moving forward. In case one of the trig rules show up, you have easy access. You can just keep referring back to that first page. Okay, does that make sense? Okay, while I'm at it, let me just go through some of these other rules and how I organize them. So these are the more obscure rules. Well, not these, but I have some more obscure rules I want to kind of show you if you want to spend the time to memorize them, that it's not too hard. Natural log and e to the u, these are the most basic ones. We should know these. And the reason why I like to organize in this form is because natural log and log base a are very similar. E to the u and a to the u are also very similar. So if you can look at u prime over u, then just know that log base a of u is going to have a very similar pattern. There's also going to be a u prime over u, but there's a conversion that has to happen, and that conversion is a coefficient of 1 over natural log of a. Okay. A to the u looks a lot like e to the u. It also involves the original function, also the exponent's derivative, but then there's a conversion that has to happen, and so it's natural log of a times a to the u times u prime. And the way I decide between these two, because sometimes you may be thinking, wait, how do I know where the natural log goes, if it's a numerator or denominator? This helps me remember because I don't see any denominator with this portion, so I'm just going to leave that natural log of a in the numerator. Here, u prime over u, I see a denominator, so that kind of gives me a hint that, okay, natural log of a is going to go in the denominator. Okay, the arc-trig rules seem difficult, but I want to show you that you really only have to worry about 3 of them. If you know these 3, you know these other 3 as well. And look at how I organized them in a very similar pattern as my trig functions. So all the C functions are together. They're pretty much the same thing. I just have arc in front of them, right? Inverse or arc in front of them. Okay, so I want to talk about the pattern here to help you if you want to spend time memorizing these rules here. Arc sine, arc tangent, arc secant. They all have u prime in the numerator. So all the derivative rules are all u prime. Okay, the denominator, they all are involving 1 and u squared. Okay, they all have 1 and u squared. It's just the way that they're merged and presented is a little different. So the way I like to fill out my, because if I'm going to write down the rules, I'm just going to write down these 3 because these 3 are just based off of them. The way I'm going to begin this is I'm going to start with the easiest one. The easiest one is the arctangent. Arctangent has no negative sign, has no square root. It's just going to be 1 plus u squared. That's the easiest one. Okay, and that's also the one that shows up the most often. And then the next is I want to go to arcsecant. Arcsecant is the most complex looking one. Okay, it has an absolute value of u, it has a square root, and it has a u squared minus 1. So everything that is complicated is showing up here. The absolute value, the square root, the minus sign. I like to do this one first before arcsine because these look so similar to each other. But arcsecant is nice in the sense that I know the u's are going to be next to each other. So that's what reminds me to put that u squared first. It's not 1 minus u squared, it's u squared minus 1. I just know that the u's are next to each other, and that helps me remember the order of the radical rule. But the nice thing is, if you can do this, the arcsine is going to be easy because you're just going to, it's going to be a little different from this. There's no absolute value. There's still a square root, but the order is going to be different. So if you can get that u squared minus 1 to show up, then arcsine will be easy. It's different, so it's going to be a different order, square root of 1 minus u squared. So that's how I build my derivative. U prime first, then I do arctangent, then I do my most complex one, and then if I can stare at arcsecant, I can build my arcsine because I know they're going to be similar but different. And if you know these three rules, then these three are easy because you're just going to rewrite them and just put a negative sign in front of them. Okay, so that's how I go about remembering these rules, just kind of breaking it down, looking at patterns. Okay. Let me go back to the tips and advice sheet. Okay, this is at the bottom of the page here. Yeah, just a couple of reminders. Oh yeah, if they're asking for maximum value on EVT, make sure you provide the Y value. If they just ask for value, that it's referencing the Y value. Okay, I think this sometimes is helpful. Know how to clear memory in your calculator, because what I've seen is sometimes students, something happens in the calculator, they enter in something strange and they can't get back to where they were before, and you can't ask for help. You can't ask somebody to, to figure out what's wrong, or maybe you can't get that screen to show up. So I like to tell students, hey, if, worst case scenario, know how to clear your memory, because if you clear your memory, it'll take everything back to where it was before. It'll put you in radian mode, and it's just a nice feature to have. So you're going to go to second memory and then 712, and that will clear things out and it'll take you back to where you were before. So let me just show you on this graphing calculator here. So if I want to clear my memory, I'll do second. So second plus second memory. Okay, and then you see that reset 7, 1, and then 2. Sometimes students, they're trying to graph and they don't know why things are showing up, or graph is not showing up. It's nice to just, because you don't know where you push the button that caused something to occur and you can't go back. You don't know how to fix it. I think it's nice to know how to reset. Also, something to point out is sometimes students have issues graphing because their plot 1 is highlighted. So just be aware of that. For some reason, I guess when you hit enter, it's just so close to Y1 that you're going to accidentally hit plot 1. And if you highlight plot 1, the graph's not going to show up. So just if you're having issues, if you don't want to reset, make sure that plot one is not highlighted. So the way that you would unhighlight it is you would just go up and hit enter again and just make sure it's unhighlighted. Okay, last piece of advice here on this sheet. Okay, when you're applying or approximating a calculus process, a derivative or integral, your units of measure will change. I think most students are pretty good with derivatives. They know that, okay, if I start off with meters per second, I'm going to get meters per second squared if I find the derivative. If I start off with ounces per minute, a derivative or slope is going to turn into ounces per minute squared. I think we're pretty good with that. What I want to make sure that we also understand is if you take the integral, that they don't change, that you make sure that you change your units as well. Okay, that means if I start off with ounces per minute, the integral process is going to push that unit to be ounces, right? If I accumulate all these ounces per minute in terms of the rate at which water is being added to a cup, integral of that is going to convert that to the total or the change in ounces, no longer in ounces per minute. So make sure derivative, integral, even Riemann sums, right? Riemann sums is also approximating involving integral. So you're going to change the units as well. You lose a rate each time you take the integral. You gain a rate each time you take the derivative. Okay, finally here, I think we've done solving differential equations in terms of x and y a lot. And years past, students have always kind of struggled with differential equations that don't have x's and y's. So I just want to remind you that if you don't see x's and y's in your differential equation and you're separating the variables, just kind of train your eye to remember that, okay, if I don't see x's and y's, it'll be t and something else. So in this case, your g is your y. So you will still cross multiply, but you group your g's on the left. Just train your eyes to see that, okay, that's basically my y variable. And then t is your x variable. So group the t's on the right and then go from there. Okay. You're not going to see any other variation. It'll be either x and y or it'll be time and something else. And whatever that something else is, that's your y variable. So, don't think that, oh, I got to learn a whole new process. It's the same process. You just have to understand that you may see some different variables when solving different equations. Okay. Okay, so if you're in a classroom, you picked up this handout. These are the last two homework assignments, homework assignment 15 and homework assignment 16. These are all, if you picked up in the packet, I put it all in the same packet. If you're looking online, I have it under yesterday's date and today's date. But these are the most recent FRQs, 2017, 2018, and then on Monday, we're going to do 2019's FRQs. And the reason that I want FRQs to be the very last thing that we do in class is because FRQs tend to be similar in terms of tone, in terms of, I think also the test writers are probably the same people or the same group of people. So there's a lot more similarity in recent FRQs than there are in past FRQs. Doesn't mean that you're not going to get those, but I want us to see the most recent FRQs, have that fresh in our minds, so we can see, the chances are higher that we can see something familiar showing up on the AP exam. Okay, so these assignments 11 through 16, they're not due until next Friday, but I would highly encourage you guys just to work through them. The more FRQs that you do, the more comfortable, the faster you'll move during the testing. I just think it's going to benefit you, assuming you have time, right? So if you have time over the weekend, please do these. I worked them out in detail. I'll have a help session Monday afternoon and Monday evening to help answer any questions. You can also reach out to me take a photo of problems that you're stuck on, and I'm happy to help you. So I encourage you guys to do homework 15 and 16 earlier than Tuesday so that you can get that additional practice that I really want you to have. And then I didn't turn it off. Okay, so on Monday we'll do FRQs for 2019. Wait, one more thing. Okay, and it's I've on my website I've begun to kind of organize where I feel are the most important documents for you to maybe look through and review. So we'll go through 2019 FRQs on Monday. I'll have the key and anything that we don't get to, I can always have a help session in the afternoon. The fall summary formula sheet. This is the formula sheet that you guys have been seeing on the recent multiple choice. So look through them, read through them, commit those to memory. Really want you guys to go in, just understanding that most formulas are not going to be given to you. So you want to spend the time to be familiar and to memorize them. Derivative and integral formula sheet. Encourage you guys to print these out and see if you can commit them to memory. If you want to do the more obscure ones, that's great, but at least the major ones, at least the 6 derivative trig rules. I think those are relatively easy to do, and you should be able to get that practice in. The tips, details, tips, advice you guys picked up. I'm also creating a document, miscellaneous and secondary AP multiple choice topics. Well, let me talk about this in a second here. First, College Board, they've released all their FRQs from 2000 to 2018. So I have a link here. Obviously, I don't want you guys to do, only if you want to. You can do the older ones as well. But I would like for you guys to at least click through it. Click on scoring guidelines, because the problem will be at the top. The solutions will be at the bottom. Look through some of the older ones and just see if you can read the problem and just formulate what you think the steps are, right? And just kind of see, okay, if you can read the problem and just formulate what you think the steps are, and then confirm it just by reading through the solution, I think that's great. If you have time, I would encourage you guys, minimal, please do 2017 to 2019. I think the most recent ones are good. I've been picking some FRQs from earlier years that I think are good, but I think if you just read through them, you can begin to kind of see how the questions are being asked, and the more that you see, I think the more chances you will feel comfortable when you're looking at FRQs on Tuesday's exam. And then finally, miscellaneous and secondary AP problems. These are topics that I didn't really get a chance to go through in class, or maybe I touched on them, or we've touched on them, but I haven't done them recently. And I've really had to kind of prioritize what I think are the most common, the highest chances of showing up on the AP exam. And then the secondary ones I kind of push to the side. But I do want to create a document with those practice problems and those practice concepts, spell them out, go through solutions for them. So such as, absolute value functions, implicit differentiation for the second derivative, just these things that I didn't want to spend multiple days on. But if you feel like you've done you feel comfortable with everything else and you have additional time, then look at this, right? But don't look at this if you feel like you still want to do more work with free response, or because those are more important. But this is less important, but it could show up. They've shown up on AP exams. So, for those of you who would like, I'll prepare this. I'm still working on this document. I should have this up later today, if not tomorrow. I'll have a key ready for you. Monday, I can have that time to answer any questions. Want you guys to have as much resource as possible going into Tuesday's exam. Okay, you guys have any questions?
Mr. Yang?
Yes.
Is the class schedule for next week normal and we just miss class?
Yeah, that's right. I think next week we're back to normal. Next
Okay.
week, we're back to normal schedule. Yeah. Was that your question, Kathy?
Yes.
Okay, yeah, so EOCs are completely done. So at least all the periods have, I mean, it didn't really affect this period much because we've had close to a full period, but yeah. Okay, good. Any other questions? Yes.
So we get an exam, we just go to the class period.
Oh, you mean on Tuesday?
Or on any exam.
Yeah, I think on any exam day, you can, but I think technically, no, you're excused from the rest of the classes. So if you want to go home after AP exams, feel free to do that. You put in a day's work, so you deserve rest. So yeah, if you have an AP exam, then take the AP exam, and then yeah, just go home. There's no penalty for, we don't expect students to show up on the day of exams to their classes. Okay, any other questions? All right, so encourage you guys to do the FRQs this weekend, review through the rules, reach out to me if you have any questions, and then hopefully I want to do a help session 4 to 6. I may be available in the evening as well, just to be on Teams to help answer any last minute questions. I want you guys to feel as prepared and as comfortable as possible going into Tuesday's exam. So that's my hope. All right, that's all I have. Thanks, guys. Hope you guys have a great weekend. I will see you on Monday.